when it was flashed. It's for random. Now, of course, you know that there's this complex model. There was a German lecturer. It goes.
Ready? Okay, let's get started. Let me have your attention, please. Welcome to the University of Tennessee Nuclear Engineering Department Cloakroom Program. My name is Lee Dodds, and it's my privilege to introduce today's speaker, as I do every week. Today's speaker is Mr. Eugene Grecheck, who is Vice President for Nuclear Support Services for Dominion Energy Incorporated in Virginia, in Richmond, Virginia. Gene received a BS in Physics from RPI in 1974, and then a Master of Science in Nuclear Engineering, again from RPI in 1975. And then several years later, in 1981, he received an MBA from Virginia Commonwealth University. He's been with Dominion Energy since 1975, and all those years working in the nuclear side of the business. For your information, Dominion has 6 reactors right now, nuclear power reactors, and they're going to a 7th. They're going to buy another one, and so they'll have 7 reactors fairly soon. The title of his presentation today is Progress Toward New Nuclear, Dominion's Early Site Permit and Construction Operating License Projects. Ladies and gentlemen, please welcome Mr. Eugene Grecheck.
Thank you, Lee. You know, sometimes when you hear that kind of a introduction, and you think about almost 30 years in the industry, there's a lot has happened. When I started, we were just licensing our North Anna plant in Virginia, and over many years, we've watched the industry pretty much go into a contraction mode and get itself ready for the stage that we're seeing ourselves at right now. But actually, I envy many of you in the audience because you're at a perfect place to watch something take off, which I think is probably going to be one of the most exciting things to happen in the industry for a very long time. Just to tell you a little bit about who Dominion is, we are the nation's largest fully integrated gas and electric energy company. We have both electric and gas retail customers in about 26 states, $44 billion in assets. You can see all the numbers on there. And actually, the history of the company goes all the way back to George Washington. When he was in Virginia, he had a very interesting project that he worked on after he left the presidency, where he was going to be building a canal to run all the way from the Atlantic Ocean over to the Mississippi River, and had plans of having this canal go across the Appalachians. And they built maybe about 100 miles or so of that canal within Virginia. And then when they hit the mountains, they stopped. So parts of that canal are still there. This is our footprint. You can see it's the northeast part of the United States. As a matter of fact, just surrounding Tennessee in this area. The yellow lines on there are the gas pipelines that are part of the company. The yellow, this yellow area right in here is the electric retail portion of the company. That's really where we started. That's where we have our gas customers. And then all of these stars that you see here are power plants. There are 4 reactors here in Virginia. There are 2 over here at the Millstone site in Connecticut, and we're about ready to close on the purchase of the Kewanee nuclear power station in Wisconsin. So you can see it's scattered throughout the Northeast. This area, the reason that we've decided to focus our business on this area is because 40% of the energy that's consumed in the United States is consumed in this area. This has a GNP, which I think if you looked in terms of countries, if you try to put it on a country basis, it's like number 3 or 4 in the world. So this is a huge market, and this is our focus area. As I said, we've been talking for a long time, and I know you've had speakers here before. Before I was preparing for this talk, I looked on the website and looked at some of the previous speakers that you've had here, and a number of people have come in and have talked about new nuclear and the reasons for new nuclear and why all the various basis for why it was a good idea. And I'm not going to bore you with those same slides again because you've seen them before. We can show you slides that show what the performance of nuclear power plants has done over the last 20 years and what the cost history is and all of that stuff. And you've seen it before, and we don't need to do that again. But I think, and one of the things we're going to try to develop this afternoon is the fact that we are moving, even as we speak today, we're moving from the stage where we have a few of us nuclear engineering diehards sitting and talking about wouldn't it be neat if the industry came back, to a point where economic decisions are being made by non-engineers, people who are interested only in the bottom line, who are interested in making money for their shareholders, who are looking at nuclear and saying, you know, the time is right to start seriously talking about this again. So this is a tremendous shift that is occurring minute by minute, even as we talk. You know, the performance and safety of the existing 103 plants in the United States, goes without saying. The regulatory oversight and the licensing process that the NRC has put into effect over the last 10 years or so has created stability, which is really what investors are looking for. They're looking for investment stability. There's been a tremendous amount of investment made in the nuclear plants. As you know, most plants are going for license renewal, so that means another 20 years beyond their existing lifetime. That requires a great deal, not only of physical investment, but in terms of just the engineering investment and then also the planning to say these megawatts are going to be available for our customers in the future. And support is growing. Policymakers, there have been a number of very positive articles in the media recently. There was a Forbes magazine article some of you may have seen just within the last week that talked about what's happening in the industry. Public opinion is rising. I'll show you some graphs of that later in the presentation that actually shows you levels of public support that most of us probably do not even imagine. And yet that's what the surveys are showing. And even environmental leaders, there have been several very well-known environmentalists over in the last several months that have been coming out for the first time and saying, if we're serious about protecting the Earth, this is the only option that we have. Just last week, there was a quote from an individual who was one of the founders of Greenpeace that said that the traditional environmental groups that are clinging to this opposition to nuclear power are damaging the environment rather than helping it. What makes this all very critical is a couple slides which I think tell the entire story. No matter what we do, and again, no one that is responsible in the energy business is recommending or suggesting that we use energy unwisely. But even with the best projections for more economy, for more energy efficiency, this is the kind of projections that are being put out by the Energy Information Administration, the Department of Energy, of what electricity demands are going to be in the United States 20 years from now. And if you look at that number and you say, well, how are we going to get there? And where is all this electricity going to come from? Well, what's happened over the last decade is that much of that came from nuclear plants. And you say, well, how's that possible? We haven't built any. Well, actually, we built the equivalent of 26 of them. If you look at what the capacity factors were back in 1990 and compare that to what they are today, that is equivalent to 26,000 megawatt plants that are essentially available now that were not available in 1990. You know, we were typically running at 65% capacity factors in 1990. Today, we're running at 92, 93% typically across the industry. Refueling outages in 1990, when I was running plants at that time, you know, we would typically take a 60-day outage and think we're doing well. People are now routinely doing outages in under 20 days. That's the kinds of performance improvements that have been taking place. So we've basically put 26,000 megawatts of additional nuclear on the grid in the last 15 years. Now, that's a good story. The bad part about that is there isn't any more of this left. I mean, we've essentially done what we can do. 92, 93% capacity is pretty much the theoretical maximum. Or the other way we can get these additional megawatts is do what we've been doing to make up the difference. And all the colors on here kind of bleed out, but you see all that red. All of that red is natural gas. And you can see that in the last, 5, 6, 7 years, almost all of the capacity added in the United States has been natural gas. Now, that sounds like a nice idea until you start realizing where this natural gas is coming from. 10 years ago, almost all the natural gas we used in the United States was domestically produced. But the domestic production has already peaked. You know, if you read some of the people that do energy projections, they talk about where do you reach that point where you start finding less than you're using. That's already happened in the United States. The only source of new natural gas in the United States right now is imported liquefied natural gas. LNG tankers bringing that gas to the United States. And where do you think that natural gas comes from? It comes from the same part of the world that we are now so dependent on imported petroleum products. So from a political and geopolitical standpoint, that's probably not a good idea either. But you can see this dramatic increase in where power demands for the last several years have come from. This has created what in the energy business can be seen as tremendous price volatility. The price has been changing by 50% in one heating season, for example. And when you are a local gas distributor and you're trying to sell that to your customers and you tell your customers, well, yes, last month it was, your bill was $50 and next month your bill is going to be $75, and for the same consumption, obviously your customers are not very happy with that. And even worse, what this creates is a dependence on gas and a non-stable price, which is driving many industries out of the United States. There, in Louisiana, for example, I was at a conference last summer where people that were responsible for economic development in Louisiana were indicating that unless something were done to stabilize the gas price, within 10 years, the entire chemical industry would leave the state. And clearly that would be devastating for the economy of the state. And then the third piece is emissions. This is the current mix in the U.S. of where our electricity comes from. You can see half of it comes from coal, about 20 from nuclear, and then smaller numbers from other factors. If you look at nuclear and renewables and hydro together, it's about 30%. So about 30% of the electricity in the U.S. is currently produced by things that don't emit greenhouse gases into the atmosphere. All right, so let's take that 30% and look at the future energy demand. And you see here's what it was in 2000. 30% of that was non-emitting. You take that same 30% and apply that to the expected energy generation in 2020, and you have a very interesting number here, which is this one right here. And that's this. In order to maintain the same 30% contribution, you would need 50,000 megawatts of new nuclear by 2020. Now, I'm not going to stand here and tell you that I think there's going to be 50,000 megawatts of new nuclear in 2020. So what is the consequence of that? The consequence is that this electricity, which is going to be demanded by the economy, is going to come from emitting sources. So when you hear political leaders talking about whether we should ratify the Kyoto Protocol or not, or whether we should be reducing our greenhouse gas emissions, realize that just to maintain the same 30% non-emitting fraction that we have today, we would need to add 50,000 megawatts of nuclear. And since I don't think that's going to happen, that means we're going to actually be emitting much more carbon dioxide in 2020 than we are today, regardless of what protocols we ratify or what treaties somebody wants to do or what some political leader says. This is the reality. So if we don't want that to happen, we need to be working on new nuclear now. All right, so is that even possible? And I think it is, and probably the most important reason why it is because back in the early 90s, the Nuclear Regulatory Commission changed the way the licensing process works. Part of this was their own initiative, part of it was some congressional pressure where they talked about changing the process, but they put this into effect, and then it has sat there basically unused on the books for the last 12, 13, 14 years. Up above here is what is the process that all 103 nuclear plants in the country currently were licensed under. And there was two parallel tracks. You started over here and you said, okay, I want to build, so I apply for a construction permit. You spend several years working with the NRC on this construction permit. They finally give you the permit and you start building. So you start going here and you're building. And you expect that over here, you're going to be done. So a couple years before you are done, you had to go back and apply for an operating license. And when you did this, you had to go through this entire design review again. And the example that I would give with this is, let's say you finally decide that you're going to build your dream house, and you go out and get an architect, and you work on it for a couple years, and you get this design all set, and you go into your local building inspector, and you say, okay, here's my plans, here's what I'm going to do. And they said, yep, looks good to us. Here's your building permit, go build. And then you say, okay, I'm done, I want my occupancy permit. And they said, well, no, we're going to go back and review your design and tear these walls out and put something else in here. And all that piping that you put in there, well, that's no good. Take that out and put something else in. That's exactly what was happening with all of the plants that were built in the U.S. today. Some of the latest plants that finally went into operation in the early 90s, they were under construction for 12, 13, 14 years. And if you think about money, somebody making an investment and tying up investment of billions of dollars in a plant for over 10 years, waiting for it to maybe start operating, you can see why most of the investment community says this is not for us. And of course, there were some spectacular failures in that process too. The Shoreham plant on Long Island was actually licensed. They actually loaded fuel. They actually went to 5% power, and then they shut it down and never ran it again because of a problem with the operating license. Seabrook stood essentially complete for 5 years in New Hampshire, waiting for its operating license to be issued, and they were just waiting because of all of the legal challenges that went into the licensing process. It's clear to anyone why the investment community said this is hopeless, and we are never going to finance a nuclear plant again. And that's pretty much what everyone believed for a very long time. Now, the new process is this one here. And it has three segments. It has design certification, which says that a vendor, a Westinghouse, a General Electric, a Reba, they can come and they can come to the NRC and say, here's our design. We want you to approve this design. We don't have any customers yet. This is not for a specific location, but at least approve our design. In parallel with that, a company can say, I've got a site. I might be interested in building a plant at someday. I don't know which plant I want to build yet, but NRC, why don't you at least approve my site? Say that the site is suitable. And assuming that you get those, you can reference a site permit and a design certification and make a combined license application. And the beauty of this is that by regulation, the issues that were resolved during design certification and early site permit cannot be brought up again. So if they were resolved, if there's a safety evaluation report that says we reviewed this item and it's resolved, then it cannot be brought up by the NRC again, and it cannot be brought up by any intervener group again. It's done. The other piece of that is that once this license is issued, you proceed to construction. This ITAC is a process by which the NRC verifies that you are constructing the plant in accordance with your application, and when that's complete, you go to operation. There is no license process in there anymore. So, of course, you get the license before you start really spending any money. So the investors say, well, if this works, this is a good idea. We can see how we could support that. The key, of course, is if it works, because this is all very nice on paper, but does it actually mean anything? So, all right, so there's several parts of this. The early site permits, of course, like I said, focuses on the site. It does not focus on any specific reactor. There are 3 applications currently under review by the NRC in the United States. Dominion submitted one for the North Anna site in Virginia. Exelon submitted one for the Clinton site, which is in Illinois, and then Entergy submitted one for the Grand Gulf site in Mississippi. Our application has gone through the site or the NRC staff review. We are at the point now where we're doing some public meetings and public hearing processes, but we would expect our early site permit to be issued about a year from now. When it's issued, it'll be good for 20 years. So for a 20-year period, basically, this is an approved site. And if we decide to do anything in the future, we can simply take that site permit off the shelf, go to the NRC and say, okay, here's the approved site. Here are the conditions that you provided for what can be built here. Here's our proposed design. It complies with those conditions. So let's proceed. Said design certification, again, is the process where the vendor can come in and get the NRC to approve a design. There are already 3 design certifications that have been issued. That's the good news. The bad news is none of them will ever be built in the United States. They were certified back during a time when cost control was not as significant as it is today. They were not optimized for being low-cost designs. They were basically just take what we have now and try to get them into a standardized design, and they're too small. So, for example, the Westinghouse has the AP600, which was a 600 megawatt electric plant. That unit is way too small. It will never be built because you just can't justify the cost per kW. But the good news is the NRC knows how to do these. There is a fourth one, again, a Westinghouse AP1000, that the review is completed. They're just now in the administrative process of getting that issued. That is a larger unit, so that one could potentially be built in the United States. There are two more that are talking to the NRC in what they call pre-application review, where you try to resolve all the issues before you come in with the formal application. So there's two of those in process. And then there are a number of other companies around the world that are actually talking to the NRC also. So there's a lot of interest in this process. And again, the key is that design issues that are resolved during the design certification process are resolved. And for the life of the design cert, which is also 20 years, they cannot be brought up again. And then finally, the combined license takes these two together. It is a specific technology at a specific site. When it approves, it gives you this authorization to proceed to both build and operate the plant. And this is currently what needs to happen. We need to demonstrate this process because this has never taken place. And this is where you go to the investors today and they say, well, okay, but we remember when people were applying for operating licenses before. This is where they got all hung up. This is where they want some confidence that it can happen. And again, given the fact that the NRC has never done this, they don't have the review processes in place. We've had the same issue for the early site permit where no one had ever done one and there was no standard review plan. There was no way that they had any familiarity with this. So we've had to work this out with them as we've done it. Well, the same thing is going to happen with the COL process. So what have we been doing? I have been, some of my backgrounds, I've spent almost 30 years with the company now. 25 of those years were either in engineering or operating our existing plants. So, it was a very technically oriented business, and we were working real hard to optimize the way that these plants run. About 4 years ago, I was asked to come over and start working on very, very preliminary discussions of new plants. And at that time, we really did not want to talk about it very much. We certainly didn't go out in public and say, here, we're looking at new plants, because at that time it was believed that if you said that and somebody from Wall Street heard you say that, they would immediately say that your company's crazy and punish you severely for it. So we've been doing a lot of things very quietly, but we did a number of things, many of which have been done in cooperation with the Department of Energy. We did a siting study, then we proceeded from that to the early site permit. We did a lot of work on constructability of can these plants actually be built, and now we've just started working on the combined operating license. So I'll talk about each of those. The siting study looked at 5 sites in the United States. We looked at the 2 Virginia sites that we own, Surrey and North Anna. North Anna is northwest of Richmond. It's in the Piedmont area. It's maybe 40 miles or so east of Charlottesville. Surrey is on the James River in eastern Virginia, right across from Williamsburg and Jamestown, if you're familiar with that part of the state. And then 3 DOE sites. And the reason we looked at DOE sites is because there was some thought at one point that perhaps that would be the way you'd be able to get these licensed. If there was going to be public opposition to the plant in the area where we were, perhaps you could go to a large DOE area where people were used to it and say maybe we can do something there. So we looked at the Savannah River site, we looked at the Portsmouth site in Ohio, and also the Idaho National Lab site in Idaho. We used what we thought at the time was probably the most sophisticated objective evaluation methodology for each of these sites, and we looked at everything we could think of, the demographics of the area, the growth prospects, the transmission capability, cooling water, seismic, everything we could come up with, and concluded that all 5 of those sites were acceptable. And the decision then had to be made on where did we think the demand for power was going to be. And I think as I look back, and the kind of the theme that I'm going to take you through over the next several slides is that we were starting to look at this from a technical standpoint. We thought the decision was a technical one. But we quickly discovered that the decision really isn't all that technical. It's really starting to get back to the economics of the business. The reason you'd want to build one of these plants is because you want to sell the product. And therefore, where do you think the biggest market for the product is going to be? And from that, we concluded that probably on balance, we were projecting that there would be a need for additional baseload generation in Virginia, probably, in the early part of the next decade. We were probably better off looking at one of our own sites rather than, certainly there's not a big demand for electricity in Idaho, for example. So we decided to go forward with the early site permit for North Anna. So on a very hot, sunny day in September of 2003, we submitted our early permit application. This picture was taken on the front steps of the NRC in Rockville. There's a number of NRC officials there, a number of DOE people. This was a big historic event because for the first time somebody's walking in with an application for something new with the NRC. And even the NRC had their photographer out there to commemorate this thing for the first time in 20-something years. Somebody walked in with a new application. Up above you see the CD. I don't know if any of you have ever had the opportunity to look at an FSAR or a document for any of the existing plants, but these typically are these huge, 20-volume, 3-inch binder type things. Our entire application fit on this CD with plenty of room to spare. And it had a lot of very interesting technological things for us, at least. For example, if you referenced something, if you referenced meteorological data, which the National Weather Service has, well, they had that data on the web someplace, and rather than duplicating it all in our application, we just put a link in the application and said, go look for it. And a lot of the backup information for our application is simply hot links within the document, and if you put it on your computer, you can get right to the original source. So that was a major event, and we've been working with the staff ever since then to work on that review. As I was saying before, the technical reviews are essentially complete. The draft environmental impact statement has been issued by the NRC. There's a public meeting in the vicinity of the plant next week, and already there are some local or national anti-nuclear groups that are planning to have some demonstrations and things at that meeting. So it will be interesting to go through that process. The safety evaluation report draft has been issued. We're currently working with the NRC to resolve the open items there. And we expect that that'll all be pretty much finished by this summer. Really, there were two focus issues that came up during the review. One is seismic. This is the earthquake design of the plant. It turns out that a lot has happened in the geology area in the last 20 years since we built any plants. And the people who are really into seismology and regional geology have come up with all new theories of how earthquakes are distributed around the United States. And as a result of that, all of the assumptions that were made about seismic design of nuclear plants for the existing generation, well, now those people will tell you they're all wrong. And basically they'll tell you that every assumption we made about structural stability and how rigid things had to be, or none of those are correct, and that the new generation needs to be built entirely differently. And so that's been quite a struggle because you've got, particularly at the North Anna site, you're talking about building a plant that is maybe a few hundred yards from an existing 2-unit plant, and they're basically telling us our design basis has to be entirely different. So that's going but we'll resolve that. And the other piece is water use. North Anna is built on a man-made lake that was created for the purpose of cooling 4 units originally. Originally we were proposing to build 4 units there. We built 2. We never built the other 2. So from that perspective, you would expect that if it was originally built for 4 units and actually construction permits were issued for the second set of 2, that the cooling capacity of that lake had been properly reviewed. But again, in the intervening 20 or 25 years, there's been a lot more sophistication in modeling of how thermal effects are on lakes. And it turns out that the capacity of that lake is not quite what we thought it was. So what that is doing for us is creating a limitation of how much nuclear capacity we can build on that site, particularly nuclear capacity of the present design, which of course at best is perhaps 40% efficient. If you did something, for example, a gas reactor that is much more thermally efficient, you could probably put more capacity there. But if you're looking at light water reactors of the existing design, we're probably looking at 1 large unit, and that's the limitation at that site. Again, we got public hearings coming up later this year. We have a meeting with the ACRS coming up this summer, and we expect certainly by June 2006 we'll have this permit. How long does that take? All right. All right, I mentioned that we were looking at constructability. We had been talking to the various vendors, and they all came in and said, you know, we've got this wonderful design here. And I think we were talking to someone before the seminar started, and we're saying, you know, that paper reactors really look nice, and there's a big jump, though, from a paper reactor to actually building one. And most of these people had not built a nuclear plant in a long time, so we were asking, you know, how much confidence can we have in your estimates when you tell us that it's going to take 48 months to build this thing? What level of confidence should we have in your statement? And after we went through some of those discussions, we decided, you know, we really need to take a look at this ourselves. We put together a group of Dominion Energy and TVA. We looked at all of the reactor designs that were currently being marketed about 2 years ago. Spent a lot of time just dissecting these things with our own construction people and saying, what does this look like? And, you know, let's get some familiarity with it. And we looked at 3 areas. We looked at constructability. We looked at what we thought the staffing levels would have to be for these new plants, because, again, we were being promised that fewer people would be needed to run these plants than the existing generation. Well, did we have any confidence in that? And then, of course, decommissioning was also interesting, because if you're going to build one of these plants in a deregulated environment, then you can't just build this into your rate base. You have to come up with some way to do decommissioning, perhaps even pre-funding decommissioning before you even build it, which, again, you'd have to have some confidence in what the decommissioning numbers would be. We did all that, and then the conclusions that you can see here concluded that, yes, we ought to go ahead. The construction technology we considered was aggressive, but we thought that could happen. Staffing, indeed, will be less. There's still some debate about, you know, exactly what that'll be, but it does appear like you'll need fewer people. And part of that is because many of the newer designs have less equipment in them. They're more passive designs. They have fewer moving parts. If you have fewer moving parts, you need fewer people to maintain it, and that should result in some significant savings. And the decommissioning is probably comparable to the existing generation. And then finally, what's currently the big item on our plate is the combined license process. The Department of Energy issued a solicitation in November of 2003 that said if anybody who has interest in coming to us and proposing a cooperative agreement that would lead to the development and approval of a combined operating license, come talk to us. And as I was, during lunch today, I was listening to some of the faculty talking about the grant process and how we do that. Of course, we were a private utility. We had no experience with dealing with government grants and going through that, so it's been an educational process there. We submitted our application in March of 2004. After extensive discussions with all of the vendors, we concluded at the time that what we needed to do was to partner with Atomic Energy of Canada. We were proposing to use the ACR 700, which was a evolutionary design of the CANDU plants that are currently built in Canada and other parts in the country or of the world. So we partnered with ACL, Bechtel, Hitachi, and ourselves, went into DOE, said, here's what it's going to take to do this project, and then waited through most of the summer before the DOE took any action on it. In the meantime, another group, New Start Energy, which is composed of probably all of the other large utilities in the country, came together with a really, really massive proposal that said we want to look at both the GE ESBWR and the Westinghouse AP1000. We haven't picked a site yet, so we want to do site selection. I mean, it's a really ambitious project that they came up with. And so they submitted theirs, and then TVA did a very, very small study to look at building an advanced boiling water reactor, which is one of the already certified designs that GE has, and building that at Bellefonte. Bellefonte is a 2-unit plant that was partially constructed and never completed. So they're almost done with their study, and we're waiting for DOE to take action on the other 2. Right after the election, DOE was clearly not comfortable, or the administration was not comfortable making announcements on these awards in the weeks running up to the November election. And interestingly enough, on November 4th, I believe it was, so 2 days or a day after the election, the DOE made the 2 awards to both New Start and Dominion that said, you know, proceed. We now have to start working on doing the contract. At the time, they had no money in their 2005 budget, so they carried over some money from 2004 and said, let's do a phase one that is really pretty much just planning, not actually doing any COL writing. And we are continuing with those contract negotiations. And then in the middle of all that, some of you may have heard that we changed our technology. I saw some smiles back there when I was talking about the ACR 700. We decided right at the beginning of January that we were not going to proceed with the Canadian design. And a lot of people have said, well, why did you make that decision? And primarily it's because we're starting to see, and this will be point number 2 in this change from technical to financial, we're starting to see that you don't really want to put yourself in a situation where your schedule is being defined by the technical issues. And since the NRC had never licensed any can-do technology in the United States, they were starting to tell us that, well, yes, we think we can license this. We don't see any issues with it, but it may take 5 or 6 years to get there. And we were saying, well, okay, that's all right, but if it's going to be 5 or 6 years to get there, and in the meantime, the whole industry is suddenly waking up and saying, we need to have new nuclear, do we want to be sitting here waiting to get this technical review done? Or should we be focusing on something that we have a little bit more confidence the review can be done quicker? And so after a lot of soul searching, because this was not an easy thing to do, we finally came to the conclusion that it was probably appropriate, if we wanted to maintain our schedule, that we needed to make a change in technology. So we informed the DOE right at the beginning of January that we were switching over to the ESBWR, which is a GE product. So this is the scope of our proposal. And the scope says we're going to help GE with their design certification. GE is scheduled to submit that application in June of this year. They're expecting that it'll take 2 years to get the NRC review of that. We'll start working on our COL application for an ESBWR at the North Anna site. We expect that that application will be ready for submittal in the middle of 2007. And at that time, a major decision has to be made, because we don't believe that any company is going to submit a COL application for a site that says to the world, I'm going to build this plant at this site, unless you intend to do it. There are some people who have been talking for several years about hypothetical COLs or draft COLs, or picking a site that you don't really intend to use, but working through the process. And we don't believe that that's real. We don't think that's reality. Because if you recognize what that means you're going to the localities and you're going to have to get all the local support, and you're going to have to convince the local governments, for example, that you need to support our application, but we don't really know whether we're going to build it here or not, so we just want you to do this because it's a neat thing to do. And we don't really think most local governments are going to do that. They're looking at jobs, they're looking at tax base, and what they want is somebody to commit to doing something. They don't want hypotheticals. So we need to make a decision in 2007 whether we're actually going to submit this COL application or not, and a lot of that's going to depend on what the economic and demand and electricity forecasts look like between now and then, and I'll talk about that toward the end. If we proceed, we need to do a tremendous amount of detailed engineering. One of the hidden secrets in the process is that the combined license and the design certification do not require detailed engineering to be completed. It's very conceptual. So you can't take the drawings and calculations that were done for licensing and hand it to a construction company and say, go build this, because there's no detail level engineering completed there. There's a lot of engineering that needs to be done before any of these plants can be built. We want to establish the project structure. Again, nothing of this scale has been built in the United States for a long time. It's not clear that the knowledge even still resides within the typical construction companies as to how to do something like this. Now, many of them have been doing construction project overseas. They believe they can bring a lot of that technology here to the U.S., but again, we just need to work through that because we haven't been doing that recently. And make the build decision. We expect that that build decision would occur in about 2010. So you would, if you make the decision, it looks like it's the right thing to do. We're going to submit the application. We're going to spend probably $200 million in terms of detailed engineering, and then once the COL is actually issued, then you have to make this decision: are we going to build it or not? So we think 2010 is about the time that'll happen. So this is what the timeline looks like. If we go through all those steps that I just described, then if we start this summer, 24 months to prepare the application, so that puts us in the middle of 2007. We think that that would take us another 2 or 3 years to get the NRC review and then get the engineering completed. So if you look at right at the beginning of 2010 or so, then sometime by the end of 2014, it is possible that a new plant could be in operation. This, I think, is the most aggressive schedule that is achievable. So as we sit here today and we talk about new nuclear, what we're saying is that there's a tremendous amount of work that needs to take place between now and then, but the earliest that a new unit can actually be online in the United States is 9 years or more than 9 years from now. And again, going back to that slide we saw way back at the beginning about 50 new nuclear units by 2020, you can see that clearly that kind of schedule cannot be the basis for an industry. We are not going to be able to have new nuclear if it's going to take 10 years to license and build the plant. And I'm confident that after all of this is done, it's not going to take that long because, again, the detailed engineering, these are going to be standard plants. These are not going to be custom built like the current generation. So once you do all of that engineering, it should be pretty much done. The design certification certainly won't have to be done again. And if people indeed are doing their site reviews early, it shouldn't take the NRC 2 or 3 years to review the COL application, again, if they're seeing the same stuff each time. So there is some hope that this schedule will be improved, but this right now is reality. And I smile because the President, as you know, just issued his budget proposal earlier this week. There is money in the DOE budget to fund the NP 2010 program, so that's good. But some of the media have picked up on that, and they said, well, NP 2010, that means there'll be a plant in operation by 2010. And obviously that's not going to be the case. We will be fortunate if a new plant is under construction in 2010. Okay, so what do we need? I've been talking to you about a lot of decisions that need to be made, about a lot of things that have to happen. What do we need to go forward? And everything that you see on the next several slides are going to be non-technical because the technology exists. Everything that we've done so far suggests to us that all the technical designs will work. So no matter what vendor you go to, no matter what fuel cycle you're talking about, all of them are technically doable. The decisions are going to be financial. And we've started to talk about things like risk allocation. If a utility is going to go build a plant, who is absorbing the risk? How do you allocate that risk? Who is responsible for it? And then, of course, people who take risk expect to be rewarded for it, so you have to start working that balance out. Energy legislation is absolutely necessary. There need to be appropriate incentives out there. There needs to be, even the Price-Anderson Act, which is a insurance situation, has actually expired for new plants, has not been in effect for the last couple of years. That needs to be renewed. We need to work through the licensing challenges of getting design certification and COL preparations, and then overcoming misperceptions. And here's where I think my challenge to all of you, as you out there talking with your peers and with people in the community, these are the kinds of misperceptions that you're going to hear about. And the challenge I'm going to leave you with is to start solidifying this base for new nuclear, to start attacking some of these misperceptions right at their base, because all of these are wrong. People go out there and they accept as a matter of faith, for example, that new plants would be too expensive to build. As a matter of fact, our own federal government, the Energy Information Administration, refuses to this day to put new nuclear into their energy forecast because they claim that it's going to cost, for maybe a 1,400 megawatt plant, they claim it's going to cost $4 billion to build. Now, of course, nobody will build a plant for $4 billion. So if that price is correct, then they're right. Nobody will build one of these things. But that price is not correct. And as a matter of fact, our studies show that a new nuclear plant, even today, even with all the uncertainties that we see in there, is comparable on a megawatt basis for an advanced coal plant. Because we're not going to go build a coal plant with today's technology, given what we expect is going to be coming down the pike in terms of emissions controls. So if you're looking at the most advanced emissions controls and figure out how much that's going to cost, it's equivalent to a new nuclear plant. New plants too expensive to operate. There are people out there that say that the existing generation has never made money. Well, that's obviously not the case, because there is a thriving market out there for old nuclear plants. You heard that we're currently buying a seventh one. In our fleet, the nuclear plants are by far the most profitable of all of our power stations. By far, it's not even close, because they are dependable, they run almost all the time, and nuclear fuel is still substantially cheaper than any kind of fossil fuel. So the plants are clearly economic to run. Construction will take too long. They'll point to plants that took 10 or 15 years to build. And yes, if a plant takes 10 or 15 years to build, it can't be built. That's absolutely correct. But plants are being built in Japan today in 48 to 54 months. I visited the Kinshan plant in China, which was the last CANDU units that were built there. Both of those were built in less than 48 months, and as a matter of fact, the second unit came in 3 months early. So it can be done. And the public doesn't support nuclear. That's the other statement you hear out there. Well, this is reality. This is a tracking, NEI has been doing a tracking poll for public support for nuclear now for 20 years. And the blue line right here are people that said, I support nuclear. And I'll show you how that breaks down in a minute. But these are basically people who went out there and said, do you support the construction of new nuclear plants or not? This blue line shows you what that looks like. And you can see that it was about, back in 1983, it was pretty evenly divided. I mean, the population was basically 50-50. You had maybe a slight plurality of people said they supported nuclear, but it was very close. And you can actually see that in 1987 or so, the opposition actually was greater than the support. Does anybody remember what happened in 1987? Well, there was a bit of a problem in the Ukraine. And so clearly there was a very, very negative period here for public opinion in the late 80s. That's also the time frame when the DOE budget was essentially reduced to zero. There was no recognition of new nuclear at all. This was a very, 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 very bleak time for the industry. And as a matter of fact, the other thing that was happening during this period was that deregulation was starting to be talked about, and people were talking about taking nuclear plants out of a regulated rate base. And I know our company was going through the same discussion about wondering whether we would be able to run our plants in that kind of environment. There was a lot of people on Wall Street who were printing very scholarly papers that said that by the year 2000, 25% of the nuclear fleet would be shut down because they would not be able to survive in an economic competitive environment. Well, clearly that was not correct. Anyway, since that time, you can see that the blue line has been increasing steadily, the red line has been decreasing steadily. So in April of 2004, we had 65% of the American population said that they supported the construction of new nuclear plants, with only 29% saying they were opposed. And the interesting phenomenon here is that when they asked people that question, they would say, yes, I support it. And the next question was, what do you think about your neighbors? And they would say, oh, no, my neighbors oppose new nuclear. And yet, then they would go next door and they'd get exactly the same answer. There was a widely held perception in the American public that I think nuclear is a good idea, but nobody else does. Now, these are the latest numbers. This is from October of 2004. And we started to break these numbers down and said, okay, you support it. Well, why do you support it? And here's the kinds of numbers we're seeing now. 80% of the American population says nuclear is important for our energy future. 67% say, I favor the use of nuclear energy as the predominant source of energy in the future. Keep the option open to build new nuclear plants, 71%. Definitely build new nuclear plants, 60%. Accept new reactors at the nearest plant. And this is where you tried to get, how do people feel about the closest plant to themselves? And they wouldn't tell them what that plant was. They would just say, do you know if there is one near you? And depending on that answer, they would say, well, do you support building new ones there? These numbers, maybe you say, well, I wish it was 90, but given politics in the United States, these numbers are resounding mandates. And yet, most people think the public doesn't support it. So I think with all of that, we're entering a new stage. We're getting to a point now where the idea that nuclear is not only acceptable, but it is necessary, is growing in acceptance. And primarily because there's really no viable alternative out there. You know, anyone that says shut down the local nuclear plant and replace it with windmills does not understand what windmills look like and does not understand that each windmill is maybe 1 or 3 megawatts as opposed to the 1,000 megawatts that they're proposing to shut down. Political support is definitely increasing. I've spent an awful lot of time on Capitol Hill over the last several months, and there are people now, but now you hear senators doing this. You know, they whisper to you in the corner, "Yeah, I support it, but I can't say it publicly." All right, but I'm beginning to see people that are willing to say it publicly. Some of you probably didn't notice, but when the president gave the State of the Union address last week, he actually said the word nuclear. Well, I can't remember the last time he mispronounced it. Yes. But he did. But he actually said the word and said it was important, which is a tremendous political achievement. The ESP applications have engaged the NRC, and I can't say that the application process or the review process has gone without a hitch, but it has been useful to engage the NRC staff for the first time in 20 or 30 years, talking about new projects and just working with them to get through this process of saying, no, you can't take a year to review it. You got to take 6 weeks that it says on the schedule, and let's get on with it. So that's been very useful, and that's really setting the stage for the upcoming license reviews. There are multiple technologies out there, so if your particular company doesn't like a particular supplier, you're not limited to that one supplier. And the financial community is starting to understand and is starting to very tentatively start talking about financing structures that can work. So the momentum is building. There are even new vendors entering the marketplace. Areva, for example, they've sold a couple designs in Europe. They are building one in Finland. They have a recent announcement that they're building one in France. They've now decided to enter the U.S. market. A few years ago, they said there is no U.S. market. Now they say there is. Financial media, the Wall Street Journal and Forbes and Business Week have been having positive articles now about the idea that, hey, this is something we ought to be investing in. There is a developing sense of urgency. We are looking at significant base load generation shortfalls in parts of the country that will be coming up, say, 10 years from now. Now, that's not universal. There are some parts of the country that will take a little bit longer to get to, but there are parts of the country that need new generation. And if nuclear is not the solution, companies will have to make a choice of what to do. And they will either go with more natural gas, which we already know why that's not a good idea, or they'll go with coal. And if they go with coal, we're going to be putting more carbon dioxide into the atmosphere. Most companies don't want to do that because it's not the right thing to do. And it's not just a technical or theoretical discussion anymore. This is now something that's being discussed in boardrooms of major companies on a regular basis. So it's not just some nuclear engineering geek somewhere in the corner who writes papers that nobody reads. This is now something that people are paying attention to. But there are some significant barriers. We've got a lot of first-of-a-kind engineering that needs to be done. We still have this licensing uncertainty issue that needs to be resolved. And there's a long memory. You know, people that lost billions of dollars that last generation, they still remember this, and it's going to take a lot to get over that. And the other piece is, which is not even a nuclear issue, is by the way the U.S. economy and the tax structure and everything is in this country, there really are very little incentives to invest money over a long period of time and expect to get a return on it. Because what happens is, let's say you're going to invest $2 billion on building a plant, and let's even assume that under the best of conditions it'll take 5 years to build it. That's $2 billion you've tied up for a period of time that you're earning absolutely nothing on. And that creates things called earnings dilution that cause reductions in your stock price. Most board of directors will not accept that because the Wall Street won't accept it. So there has to be ways to be able to overcome that, and that really has nothing to do with nuclear. This is any large infrastructure project that you expect the private sector to do in this country needs to have some way to finance these things without putting all the risk on the shareholders and then expecting them to say, oh, yeah, well, that's a good idea. And depreciation, it is actually easier to depreciate, and you get a faster return on meat processing plant, you wanted to process chickens, you would get a much better depreciation return than on a power station. So, the imperative is that without nuclear, we cannot meet the objectives that most people in our society accept. Things like diversity of fuel supply, not relying completely on importation of foreign fuel. Price stability. Again, if we depend totally on natural gas, we are going to be completely dependent on weather on a daily basis, on a seasonal basis, or on what demand is out there in the rest of the world. And as I mentioned, I was in China back last fall, and you can watch what's happening there in terms of construction and development. That economy is growing at a compounded rate of 15 to 17% a year. As a matter of fact, they told us that they were working on a slowdown. The government was going to clamp down on growth and hopefully reduce compound growth rate to 14%. And yet, our economy grows maybe at 2 or 3% a year, and we're happy with that. If we don't seize the opportunity to go with new nuclear now, it'll inevitably lead to environmental consequences that we don't want and economic effects which are devastating. So we have an opportunity. There's a window right now. The window is open. People recognize it. But, as very often, historically, you can look back and see where people had opportunities to do things and they let the opportunity slip by and the consequences were terrible. So the challenge to you is we need energy legislation. It is a shame. It is a disgrace that given what's happening right now, in 4 years, Congress has not been able to pass an energy bill because of various political, considerations of one thing or another. And I think one of the things that everyone in this room needs to do, I know I've done it as a citizen, private citizen, not as a representative of my company, is to get with your legislators and tell them we need energy legislation and we need something that encourages investment in the infrastructure of the economy with appropriate incentives for new nuclear. Help reinforce public support. You're going to talk to people and they're going to tell you the same things that I showed you on that slide. They're going to tell you that those things are facts. And they're not facts. It's time that we just start pushing back on that. And finally, you're doing the right thing. You're in the right area, but encourage people to pursue careers in nuclear, and not only engineers. I'm talking about people at all levels. We're talking about a revival of an industry which unfortunately is currently composed of a demographic that is, 10 years or so away from retirement. If we don't do something soon and we don't get people coming into this, we may start building these plants and there'll be nobody out there to run them. So the next piece of last part of the puzzle is to start getting people interested in this. And I think, again, I know you are, but I think it's time to get that same enthusiasm with others. So with that, thank you.
Okay, we have time for a few questions and comments. Okay, Mario.
Oh, do you plan to do on-site long-term spent fuel storage for your 7 plants? Not depending on your plant,
No, we have on-site storage at all of our plants right now. Our Surrey plant in Virginia was the first one to have independent spent fuel storage with dry cast. We have dry cast at Surrey and North Anna. We are right in the final stages of installing them at Millstone. So our current capacity, or the licensed capacity for dry cast, is for the current licensed lifetime, including license renewal, at those sites. And Yucca Mountain is important because I think we need to be able to close the fuel cycle in some way or another, but it's not necessary for the next generation.
Peter?
I'm always awed by the decisions you have to make. And I was wondering, it's a general question. In the academic environment, there are courses taught fall sometimes under decisions and uncertainty. My question to you is, do you have a partially quantitative, formalized approach, or is it educated seat of the pants? How do you make decisions?
The answer is yes. There is a lot of educated seat of the pants. There's a lot of dependence on some of us who have been doing this for a long time. But we do have models, and we do sensitivity studies, and we do have ways of attaching probabilities to events and trying to calculate what we think the consequence of that will be. And as we constantly tweak those models, That's what leads to decisions. For example, is a decision that we made at the end of the year that we needed to move faster and we needed to not put ourselves into a risk situation where we could get caught by a technology that was promising but not yet licensed if all of this was going to start happening faster than we thought it was. So that, as a matter of fact, it was the quantitative model that led directly to that decision.
Is there a competitive nature between you and New Start? How does that work?
There is competitive nature, but obviously we need to work together. The issues that New Start and we face are the same. We do have a very close relationship with them. We made a decision not to join New Start mostly because our company wanted to have its future in our own hands rather than having to work through a committee. But I wish them all the luck, and I'm sure there's room for both of our groups.
Larry?
The AP1000 is a couple of years ahead in the licensing process. Would you be able to pick up the schedule had you gone that way?
We could, but the AP1000 is being marketed as a twin unit with 2 units. And by the way they're designed, in order to get their cost structure to be competitive, you really need to build 2 at the same site. And we cannot build 2 AP1000s at the North Anna site because of the water restrictions that I was mentioning before. So we really had to make a decision to go with the largest single unit we could find rather than depend on 2 units because we just can't get that megawatt capacity there.
I have a question. I have several professional colleagues at AECL and also at GE, and I was wondering the reaction of the Canadians when you made the decision to abandon the ACR 700 and pursue the ESBWR. What has been their reaction? Well, clearly they were disappointed. What they did as a result of that decision is that they decided to start looking at a larger unit. The AC 700 was being marketed as a twin unit, again, 2 700 megawatt units, and they are now looking at a 1,000 or a 1,200 megawatt unit because they think in the international market that probably is more attractive. The 700s were actually quite attractive in the U.S. because of the way the electricity grid is arranged here, but in China, for example, where they need to build as many as they can as quickly as they can, it makes more sense to build larger units. So partially it allowed them to move to a different concept and say, well, okay, we'll put the U.S. market on hold for a while and move to the international market, but obviously they were disappointed because they saw this as a way to enter the U.S. market.
Okay. Do we have any other questions or comments? Okay. I think everybody who's here today, now I see a few. I see a few new faces every week. I started to say we have no new faces, and everyone knows that we have a reception after this. But for those of you that are new, we do have a reception immediately following today's presentation. It's downstairs on the second floor, and everyone is invited. There's food down there. But before we adjourn, let's express our appreciation again to Eugene for his presentation. All right.